Okay, this is the IXL Solve One-Step Equations reteach. It was IXL 7.s.6 for you. And before I do this reteach lesson, I just want to go over the steps to solving equations. So we have 5 steps to solve equations. The first step is the combine step, and that is going to be when you combine like terms, use the distributive property if needed. We're not going to need this for one-step equations today, but we will come back to that later. Then we have split. Split your equation down the equal sign. Whatever you do to one side, you must do to the other. This is the fundamental of solving equations. Whatever we do to one side, we have to do to the other because the equal sign represents a balance. And if I do something to one side of an equation without doing it to the other, I'm not going to stay balanced, okay? So we're going to show that by splitting our equation in two. Then we have the isolate step. The isolate step is when we isolate the variable, we get it to one side of the equation if needed. All right. Again, this is not going to come up in this lesson. This is going to come up further on down the road to getting to one side, but we are going to show how to isolate our variable today. Then we have the inverse operations, the perform inverse operations in reverse order of operations until the variable is alone. The reverse order of operations is important, but that's not something that we get into until the next lesson, which is solving two-step equations. And then finally, the check step, which you should do no matter what kind of equations you're solving, which is to check your answer by putting it back into the original equation. So in the end, we're going to be talking about combine, split, isolate, inverse, check, and I'm going to be using those 5 terms over and over and over and over again. Every time we solve an equation, we're going to talk about combine, split, isolate, inverse, and check. All right, now, the first one I'm going to start off with is a very basic one. It is 2w equals 4. Now, this is represented by the thought process that 2 times some unknown number equals the value of 4. Now, you can probably, in your head, understand that the answer is 2. 2 times 2 equals 4. But how can we use our steps, combine, split, isolate, inverse, check, to get that answer if we couldn't do it in our head? Well, combine. First, we're going to look at the left side of the equal sign, and we have only one term, so we can't combine it with any other like terms. We look at the right side, only one term. It has no like terms to combine with. Split, we're literally going to draw a line down the equal sign to split our equation to 2. Again, to remind us, whatever we do on this side, we have to do on this side, or vice versa. Isolate. We're actually going to draw a box around our variable. When we're done, that variable, what I have boxed, should be the only thing on the left side of our equation. That means that we have to get rid of everything that's with it. In this case, there's a 2. Inverse. Now, what we have to do here is we have to identify what is the operation being done to the w. In this case, 2w means 2 times w, so I'm going to use the inverse operation of multiplication, which is division. So what I'm going to do whenever I'm using multiplication or division and I'm using the inverse, I'm going to use the exact same number, just the inverse operation. So since I'm multiplying this by a 2, I'm going to use a 2 for division, and I'm going to do the same to this side. And now I'm going to be getting a result, so I'm going to put a line under my entire equation. 2 divided by 2 is 1, which is great because now we have 1w, and 4 divided by 2 is 2, so we have 1w equals 2, or w equals 2. When I do my check step, 2w equals 4. I plug 2 in for my variable. 2 times 2 equals 4. 2 times 2 equals 4, and 4 does in fact equal 4. Therefore, my answer is w equals 2. When I go to the next problem, this is an example of when we're solving addition or subtraction. So we have r minus 3 equals 9. And I'm going to use the same thing, combine. Even though we have 2 terms, they are unlike, so we can't combine them. There's only one term here. Split, isolate. I draw a box around a variable. Inverse. Now, I have a negative 3. This is in the form of addition subtraction. So whenever I have addition subtraction, I'm going to get rid of it or eliminate it with the opposite. So the opposite of negative 3 is positive 3, and I have to do that to both sides. Negative 3 and positive 3 are completely eliminate each other to become 0. That gives me r on this side and 12 on this side. When I go to check, r minus 3 equals 9. 12 minus 3 equals 9. 12 minus 3 does in fact equal 9, so 9 equals 9. My answer is 12. R equals 12. All right. On this problem, we're actually going to I'm going to have you come up with the answer, but I just do want to show you that there are times where we have an equation where the variable that we're trying to solve for is on the right side of the equation. Now, some students like to solve it just as it is, and we can still use the exact same steps. Some students would prefer to turn it around and make this 3j equals 15, and you are allowed to do that as well. If 15 equals 3j, then 3j equals 15. They're the same thing. Remember, it's a balance, so it doesn't matter if you turn around. It's still the same exact thing. These are still balanced. What I want you to do now is combine. There's nothing to combine. Split, isolate, and then what would the inverse in this problem be? Okay. The inverse that we'd be doing, since this is multiplication, would be dividing both sides by 3. So we divide this side by 3, we divide that side by 3, we get 1j equals 5. When we plug it in to our original equation, 15 equals 3j, 15 equals 3 times 5, 15 equals 15, check, so our answer is j equals 5. All right, now, in this case, this is an example of what division would look like. This is t divided by 3 equals 4. So after we go through our steps, combine, nothing to combine, split, isolate. Now, since this is division, the inverse of division is multiplication. I'm going to show that by using multiplication, and I'm always going to write my multiplication up here. The reason why is because this identifies as a fraction. So if I were going to multiply, it would be 3 over 1. 3 over 1 times something over 3. I can cross reduce, okay? So that's essentially why we're always going to do it that way. I'm not going to show the over 1 typically. I'm just going to put the multiplication of 3 up here, and then I'm going to show that they cross reduce by doing that. Now I have to do the same to the other side, and that leaves me with t equals 12. And if I plug 12 in for t, 12 divided by 3 does equal 4, so that's our answer there. For this problem, again, we're on the right-hand side, but what we can do is we can turn this right around to become z plus 17 equals 65. There's nothing to combine, split, isolate. The inverse here is a positive 17, so we're going to do a negative 17. And we're always going to use the opposite whenever we're eliminating a constant, which comes up, which is important coming up later on in two-step, that we identify the 17 as a constant. And then when we go ahead and we do 65 minus 17, we have to borrow. We get 48. So our answer is 48. And again, I would use the check step. I just don't want to make this too long for you right now. All right, what I want you to do now is I want you to solve this problem as it stands. Now, again, when I say you can solve it, you can change the order, but I want you to solve and get an answer for C right now. Okay, hopefully what you did, whether you switched it or not, I am going to switch it just because I find that most students do, is you get C minus 64 equals 16, split, isolate. This is a constant, it's a negative 64, so we add 64 to both sides. That will eliminate that, leaving us with just C equals 80, and hopefully that's the answer that you got. All right, on to the next question. Now, in this one, again, we're in the correct order. The numbers are getting a little bit bigger, but the steps are the same. So I would like you to try to solve this question now. Hopefully, as you solve this question, you started with b minus 60 equals 33. You split, isolate, identified the constant as a negative 60, so started using positive 60 to both sides. Again, even though the numbers are getting bigger, it doesn't change a thing about how we solve it, and so hopefully you got b equals 93. Now again, this one is a tougher question. The numbers are getting bigger. That's okay. How we approach these is exactly the same. So now we have negative 17 r equals 918. So what we're going to do, combine, nothing to combine, split, isolate. Now this is multiplication. The reason why I wanted to use this as an example is because I told you we eliminate constants with their opposites. When we eliminate multiplication or division, we're going to use the exact same number, and I'll show you why. This coefficient is negative 17. We're going to use division on both sides, and we're going to divide both sides by negative 17. The reason why we're not using positive 17 is because our result, what we want is to solve for r. We want to know what r equals, 1r. If I had used a positive 17, then I would have been doing negative 17 divided by positive 17, and that would have given me negative 1r, not r. By doing a negative 17 divided by negative 17, the negative divided by the negative makes a positive, and 17 divided by 17 makes 1, leaving me with 1r. There it is right there. And then I have to do 918 divided by negative 17. A positive divided by a negative is a negative. 918 divided by 17 is 54. If I plug that in, it does make sense. A negative 17 times a negative 54 equals a positive product. Here, again, we have the same thing, except now we have division. S divided by negative 19 equals negative 21. We're going to combine, split, isolate. Now we're going to use, since we have division, we're going to use multiplication. And we're going to multiply both sides by a negative 19. Because once again, the negative and the negative become positive. 19 over 19 becomes 1, leaving us with S equals, and the negative times the negative is positive here. 21 times 19 is 399. Okay, now I want you to try to solve this problem right now and take a minute to see what you get. Okay. Hopefully, as you solve this problem, you multiplied both sides by a negative 22. When you multiplied both sides by a negative 22, you got negative 638. Okay, there's two more problems that we want to get through. So this problem right here, I'm not even going to ask you to solve it at first. First, I just want you to set it up. Negative 11b equals negative 990. And I want you, after you combine, split, and isolate, I want you to tell me right now, what would you do to both sides to isolate b? All right, so to isolate b, this is multiplication, so we are going to use division, and hopefully you said that you would divide both sides by a negative 11. Again, make sure that it's, when you're using multiplication or division, you're doing the exact same number. If it's a negative, you divide by a negative. If it's positive, you divide by a positive, and that would get you b equals positive 99. All right, finally, this is the last question I want you to do. I want you to do this completely on your own. All right, now that you've finished that problem, hopefully you set this up as g plus 910 equals 190. You split, you isolated, you used a negative 910 to eliminate a constant of 910, did a negative 910, and then hopefully after you did that, you recognize that this is a positive, this is a negative, so you subtract 910 minus 190, and you got 720, and you recognize that the larger absolute value was negative, so your answer is negative 720. I hope that this clears some things up. If not, please come see me, and I will help you in any questions that you have. Have a great day.